In the lesson with product to sum formulas and sum to product formulas, we were able to prove where these came from by using the sum difference formulas for sine and cosine. It turns out that these formulas and these formulas are all equivalent. This means you can transform these equations into these. So let's choose one from here and transform it to an equation that appears down here. So let's prove the formula for the sum of sine of alpha and sine of beta, which equals this expression here. And to do that, we're going to use the formula up here that connects a sum of sine and sine. So we're going to do that from this equation up here. We will do this as follows. I'm going to let alpha equal u plus v over 2 and beta equal u minus v over 2. I'm going to do that in this equation here, and then hopefully reduce it to this equation down here. First, a quick observation. If you add alpha and beta as I've defined them, which is u plus v over 2 plus u minus v over 2, what happens is you'll have u over 2 plus u over 2, because the v's will cancel. We'll have 2u over 2, and it turns out that this is just equal to u. And likewise, if you have alpha minus beta, which is equal to u plus v over 2 minus u minus v over 2, something very similar happens. This time the u over 2's cancel, but we'll end up with a 2v over 2, which is equal to v. So on the next slide, to get this equation, what I'll do is, in here, this alpha plus beta, I'm going to call u. This alpha minus beta, I'm going to call v. And then this alpha, I'll replace it with this term, and this beta, I'll replace it with this term. I will simplify it and see what we end up with. So this was our equation. Here we had an alpha and a beta, but we're going to call those u plus v over 2, and we'll call this u minus v over 2. And then over here, because this was alpha plus beta, we're going to call this u. And because this was alpha minus beta, we're going to call this v. So our equation is, let's rewrite it, sine of u plus v over 2 times cosine of u minus v over 2 is equal to 1/2, and we can simply write this as sine of u plus sine of v. To solve for the sum of sine of u and sine of v, I'm going to multiply 2 to the other side. So this whole thing becomes 2 sine of u plus v over 2 times cosine of u minus v over 2 is equal to simply sine of u plus sine of v. Now this is written in terms of u's and v's, but this is precisely the sum formula for sine. All you need to do now is just call the u alpha and the v beta, just relabel it, and we actually end up with the identity. So that is sine of alpha plus sine of beta is equal to 2 times sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. So this is a proof of where this equation comes from, but the thing to point out is this is basically showing that the product to sum and the sum to product formulas are equivalent. You can simply transform one to the other by using a substitution.